morning, everybody. It's a pleasure to have all of you here at the webinar. I'm Valentina Tegas, I'm Policy and Project Management Officer at EMSO ERIC. It's a pleasure to start the EMSO webinar diving into ocean research with EMSO Physical Access Program, opportunities and projects highlights. Today we are going to introduce who we are at EMSO and what is our EMSO Physical Access Program. And we are very glad to have also three hosts here, three researchers who experienced the physical access and who can bring their experience in the webinar. EMSO is the European Multidisciplinary Seafloor and Water Column Observatory. We are a European Research Infrastructure Consortium. We are a distributed research infrastructure consortium, and we are mainly based on 8 country participations. We have 8 country members, and we have 11 cables and standalone observatories, plus 3 test sites. In the map, you can see the different observatories and the test sites. We are spread around Europe. We are in Romania, in Greece, in Italy, in Spain, in Portugal, in France, in Ireland, in Norway. And we have a total of 25 institutions involved in the organization. Our main thematic pillars are 4, and they are marine ecosystem, climate change, geohazard, and technological challenge. We are working with within 3 different domains: hydrosphere, geosphere, and biosphere. Our mission is to support the research community in investigating marine ecosystems, climate change, and geohazard, in order to achieve a sustainable management and protection of the marine resource, and to understand the complex interaction that are among the geosphere, biosphere, and hydrosphere. Our main research challenges, research infrastructure challenges, are related to the blue growth strategy and are specifically the global ocean warming and acidification, the impact and sustainability of the marine resource exploitation, the real-time observation and early warning systems that are for earthquakes, but also for tsunamis, the marine ecosystems and climate change mitigation, and the Earth interaction within hydrosphere, biosphere, lithosphere, and atmosphere. We try to ensure and access high-quality marine environmental data. If you would like to reach us for whatever reason, you can find us at the website www.emso.eu, and you can contact us also via email and via phone. So now I would pass the floor to my colleague Simon, who will present us the main feature of the access program, the physical access program, and then we will continue with the 3 invited speakers. For the participants, if you want to submit questions, you can directly write them in the window, and then we can submit the questions to the speaker after the presentation. So, Simo, the floor is yours.
Thank you, Valentina. So I will present the physical access service. We started 3 years ago at EMSO. A service is something that the research infrastructures need to provide to the community to advance their research. So here we are trying to help you with providing this service to perform experiments at our sites in real ocean conditions. We call it physical because in this case, you go to the facility or you send your instrument there as opposed to just accessing the infrastructure data, no? So it's really a physical access action that you perform. Our program is very similar to the TNA actions from different EU-funded projects. But since we are an established ERIC, we can provide it in a continuous way. And it's like a permanent service we offer, no? So it's not just a few calls during the project. It's continuous, and like that, it's always available. So every January we launch the call that lasts for the whole year, and every January there can be some differences with respect to the previous call. So it's a service for external users. The users can be from public institutions or private ones. From public institutions, it can be universities and research centers, and private like SMEs and industry. And the service offers access to the EMSO sites for testing technologies and realizing experiments. The duration of the access does not have a specific limit, but it can be up to 2 years or even more if the project requires so. This is why, as I was mentioning before, being a permanent infrastructure allows us to have more flexibility in the duration and so on. So what is this access about? The access is like you as a user can bring your equipment or system, and you can deploy it next to at an EMSO site next to the site's infrastructure. So you can use the data that the infrastructure is collecting to, for example, check with your equipment, to give let's say the context of what you are doing. It can be given by the site's instrumentation, no? But also you can install your instrument on the site, on the platforms that the site is offering. Some of them are cabled of the sites we are offering, so you can even have real-time access to some instruments that you install on the site. Or if you can also kind of install them in a standalone mode. So you can, for example, if there is a buoy or a cabled observatory, you can just install it with your own electronics and your data acquisition systems. They can be working independently, but very close to the site. And this way the data of the site is very meaningful for you, for your experiment. And also we offer, since we are a consortium, we offer that you can access several sites within the same project. So you can, for example, within the same project, do an experiment in the Mediterranean Sea and then go to the Atlantic, or do something in a shallower place and then go to a deeper place, or opposite. So we are very flexible on that, and we avail of our different sites, which are very different from each other, to provide you the best service. So the regional facility, the people that work on the sites, they will help you with the logistics, with the deployment and recovery of your systems. They can provide you data collected previous to your experiment. They can help you interface your equipment with their site if it needs to be installed in a real-time node or something. It can be done as well. And they can provide you training if it is needed for the experiment and co-development. EMSO also provides up to 15,000 euros for if you need to travel to the site, if you need to buy something or calibrate something that is necessary for the experiment, to ship your equipment to the site. Also, if some operations are needed, some divers, and so on. If you need to adapt your system to the site, it can also be in this kind of budget. So this is the map of the facilities that are in EMSO. Not all of them are available now on physical access. But as you see, we have 3 shallow sites and then observatory sites. The shallow sites, we call them test sites. They are very easy to access. They are usually close to the shore, like 4 or 5 kilometers away. So you can go there and access them very easily. They can provide divers to go install your equipment or systems. And they have very great technical support with engineers and so on. Usually these sites, they are at the cutting edge of the technology. So you can see cameras, more artificial intelligence applications, and so on. Although the others, some of them also have these technologies. So the others are like the observatory sites. They are deeper, they are more offshore. The logistics sometimes is more difficult. You need to maybe get on a ship with the user to go install your equipment. But also we have remote access, so maybe you can just ship the equipment to them and they will do it for you. And some of the observatory sites are cable too, so you can really test your technologies at very high depths and have real-time communications with your systems. So for this year, we have 6 facilities, 2 shallow sites, and then the others are like observatory sites. The procedure to apply is easy. You need to send us a letter of intent, which is 1 page. You can find it on our website, and then a project proposal of 6 to 10 pages. To do the project proposal, the facility will help you, because the project proposal needs to have some interaction with the facility, and it needs to be realistic and according to the facility capabilities. We are available every 2 months, so you can send the proposal anytime, and we have all these deadlines every 2 months, and then so when the deadline comes, we pick all the proposals, send them for evaluation, and get back to you as soon as possible. So it's quite a fast way to access our sites. The evaluation criteria is here. You can see it on the website, but mainly we evaluate the scientific and technical objectives. We evaluate the quality of the methodology, the scientific and technical excellence of the user group, the international collaboration, and the bonus points if we see that it has good links with the industry. Then once the project is approved, we sign an agreement with you and EMSO for the grant and the data policy and so on. And then one agreement with you and the facility for more technical things about the project, like operational things. If you need to get on a ship, maybe there's something to do, or if you bring a very expensive equipment, there needs to be some clauses on that. Things like that. So as a summary, EMSO can be your partner for performing novel experiments at sea in real ocean conditions, helping advance your science and technology development with the support of experienced engineers and scientists. The process is simple, and the execution period is flexible, so it allows you to focus on the project developments without time constraints or continuous reporting. So far, we granted 10 projects, 2 of them to universities, 5 to research centers, and 3 to private sector. I will take just 2 minutes to explain the projects we had. On the left, the ones that will be presented today, so I will not go through them. But on the right, for example, one awarded to Spanish Oceanographic Center to access the Iberian margin in Portugal to test some new systems to deploy landers. One from Marine Institute in Ireland accessing the Cretan Sea to deploy different CTDs and do intercalibration experiments. And one from the National Oceanographic Center from the UK accessing the Western Ionian in Italy to do some work on DAS, on the optical fiber they have at the Western Ionian. And just finally, last month, we presented more industrial projects. On the left, this is one granted to Research Institute of Sweden. It's a research center, but it has a very strong industrial component. This project is trying to see how the biofouling affects the cables with different paints. On the right, we have a sensor from AMB Sensors, pH sensor, and to check the biofouling. And the last slide is about a project from CLS in France accessing OPSI to test a wooden buoy to see if how the buoy performs. So it's nice because they have the OPSI observatory next to the buoy and they can see the ocean conditions. So for example, if there is big waves, they can check if the buoy is not transmitting well and so on. So this is a kind of experiment that can happen. And the last one is an experiment of seagrass blue, accessing also OPSI and testing how the seagrass can absorb the carbon and also how it can regenerate and bring marine life into an artificial pod that is like a prototype. But then if it works, we can scale it up to bigger surfaces. So that's it from my side. If you need anything more information, you can contact me here and the group. Thank you very much. And Valentina, you can go ahead. I will try to...
Thank you, Simo.
Stop the sharing.
Please stop sharing.
Yeah.
Now it's the time to hear about the experiences of our success cases. And the first would be Dr. Christoph Waldmann. Christoph Waldmann is a senior scientist at the University of Bremen. He's also director of MARUM, the German Center for Marine Environmental Sciences. His research projects refer to the development of new methods of the efficient long-term observation of processes in the sea. And today he is here to present the project that was implemented in our EMSO facilities, that is named Advancing Ocean Observation with Robotics and AI, the TRIPLE-Vtest Campaign. So Christoph, the floor is yours. Thank you.
Thank you very much. I will share my screen now, and I hope you can see my screen. Is that right?
Yes, that's perfect.
Okay. So again, thank you very much for inviting me. I'm going to talk about a test campaign that we carried out in 2023. And that was at OPSI Observatory. And as you already heard, it has something to do with robotics and AI methods. And what you see on the pictures are the team members of OPSI operating at the buoy station. Okay, so the challenge is ocean observations only provide a snapshot. And actually, this is partially covered here by, anyway, so maybe I can move this. That take place on different spatial and temporal scales. So, and extending this observation with additional permanent multivariate stations, it requires a lot of funds, and maintenance and service is also another issue with that. So therefore, mobile platforms can be an alternative to work with and to collect additional environmental information. Okay. So for us, it was a fantastic opportunity to use the EMSO infrastructure. We had this, what already had been mentioned, easy access. And what we want to do is repeated tests of the equipment. And therefore, it was good to be close to the coast. And we had labs available at OPSI, machine shops, and also electronic lab, and the support of the team. And for us, it was also important to have the expertise that has been provided by the personnel. And that was actually instrumental for the targeted results. Okay, so what did we have in mind? We wanted to deploy and operate an autonomous underwater vehicle close to the OPSI station. As I mentioned, we want to extend the footprint in a way from the OPSI station, and we were just focusing on CTD profile. And with AI in the back of our head, we were looking for repeated patterns, features in these CTD profiles. And finally, as you may know, physical models are not working very well in the coastal environment. So maybe we even get an idea on how to use AI methods in the coastal environment. Okay, what you see here is actually a result of a series of CTD profiles. And 0 means this is this EMSO OPSI station, where we collected the that case temperature profile. And then you see as we are moving away from the station, so away from the coast as well, the profile is actually changing quite rapidly. So what is the reason for that? It's probably an eddy that was passing close to the coast, and there was some ingress of warm water. And when you look at remote sensing pictures, you actually see those type of eddies that could affect this measurement. And also, if you think about AI methods, typically you want to have a huge amount of data. In that case, if you want to say, all right, so we take a profile at the OPSI station and want to predict such type of event, it's probably very difficult. So you need additional information, which we didn't have available at that time. In the end, you know, just to summarize this idea of AI, you can use AI and ML methods for different purposes. In this case, we wanted to fill data gaps. So, but you know, with these processes that we see here, it's probably very difficult. Okay, I mentioned already, the OPSI team were our expert advisors to carry out the instrument and to carry out the test. And we also got a lot of support for our technical service and maintenance work. And you see here the picture of the port, which we used to start our missions. And it took us about 10 minutes or 15 minutes to go to the pool station. So what I can say that was our experience was very positive. So we enjoyed it a lot. We got a lot of support, and the application procedure was clearly outlined. So I can really confirm what has been said just before. And so scheduling and actual tests were carried out in close coordination with the OPSI operators. They also have their experiments running, but it was very smooth, so no problem at all. They also gave us advice what a good time window would be. And so, yeah, with this overall process of application, there were actually some misunderstanding or ambiguities regarding this, our justification of the TNA action. But finally, we could resolve it. There was some revision of our proposal carried out. And in the end, everything was accepted, and we were feeling good about that. Yeah, I mentioned this already. Complexity of coastal processes are very high, but in any case, people would like to know better about what's going on. not just about CTD profiles. Think about this biodiversity issue. And so you need all these background parameters like oxygen, saturation, so on. And the concept of the footprint of the observation station is connected to the idea of quantifying representativeness of the observation. And so it's actually the same, you know, talking about representativeness and footprint. And it more or less means if you measure at a certain station, what does it mean for the immediate environment? Is this the same or not? Here you see now a picture that I took from the MINCE project. I'm advisor for the MINCE project, which is coordinated by CSIC in Barcelona. And there you see some ideas that deals with uncertainty. So if you take a measurement at one spot, is this good or has it any relevance? So there's a lot of discussion going on about, shall we have only few measurements with high accuracy at certain measurement spot, or shall we use low-cost sensors at different locations? So where is the trade-off between these two? And there's still a discussion going on that, but I think this test that we carried out can also contribute, at OPSI can contribute to this discussion. Yeah, we had some challenges, some technical challenges that was related to our commercially available AUV that showed actually some fundamental software problems. So we were not able to carry out the test as expected, but in any case, so we did our best and had also the CTD profiles collected. And so in some aspect, we were quite lucky because as you saw from the pictures, we had very calm weather conditions, and the weeks before were stormy. You know, if we had chosen a different week, probably wouldn't be able to carry out any tests. So that was good. But on the other hand, this also led to this more complex spatial patterns of ocean properties, which I showed on one of these slides before. Okay, so we actually feel very much encouraged through the test to explore in more detail this interplay of modeling efforts and observation at this single spot for better understanding of ocean processes. So I think this will be the future to use this mobile platform. And so we are discussing with the operators of OPSI whether we can repeat the test or how we can extend the scope of what we have done in 2023. Okay, this is my final slide, and I would like to thank EMSO Eric very much for their financial support of the test, and we actually enjoyed very much the technical support by the OPSI team. Thank you very much. That's all I wanted to show.
Thank you, Christoph. Thank you very much. I would ask you to stop sharing.
Yes.
I see in the chat there is a question that will be addressed during the Q&A session. And now I would like to move to the next speaker, Clara Manno. Clara Manno is a biological oceanographer at British Antarctic Survey in Cambridge. She is also honorary lecturer at the University of East Anglia in Norway and is future leader fellow at the United Kingdom Research and Innovation UCRI. Clara's main research interest is to understand how human-induced environmental changes affect the marine ecosystem and biogeochemical cycle. And today she's giving us the experience she had in the project investigating microplastic impacts on ocean carbon sequestration, the CUPIDO project. So Clara, the floor is yours. Thank you.
Okay, thank you. Thank you for the nice introduction, and hello to everybody. I just want to give a very quick overview about the CUPIDO project, which is a project funded by the UK Research Innovation. The main objective of this project is to understand, for some reason, my animation doesn't work. Sorry. I cannot move the... I was working before, as you said, Valentina.
Yeah. So maybe the test that we did was not so...
Oh, and we are probably now
Okay.
it's going. Okay,
Okay.
now it's
Yes.
working. Okay. Okay. Sorry again. So the main objective of CUPIDO is to understand the interaction between marine ecosystem, plastic pollution, and marine carbon cycle, and how this interaction can impact the climate change. This is a very important question because currently the climate change and microplastic are regarded as separate issue. However, we know that plastic waste and plastic production directly impact climate change. And at the end, we also know that most of the waste of plastic end up in the ocean, which have a detrimental impact on the health of our planet. This is because the ocean provide a fundamental ecosystem service to our planet by mitigate climate change and absorbing a huge amount of CO2 emission. One of the main processes that promote this mechanism is the uptake of CO2 from the atmosphere by very small organisms that eventually promote the export of carbon and then the storage of carbon in the deep water layer. Main player of this mechanism are the zooplankton, beautiful organisms that act as a highway to the transport of carbon from the surface to the deep ocean. Now, the problem is that when plastic ends up in the ocean, start to fragment and become very small, so tiny, also known as microplastic, that can also interact with very tiny organisms, such as zooplankton, that can eventually ingest them. So the main question of CUPIDO that we want to address is, can plastic pollution counteract the ability of the ocean to store carbon? And the hypothesis is that zooplankton promote the sinking of plastic in the water column, but when this happens, also decrease the capability of zooplankton to export carbon. We approach this project by fieldwork activity that use different kind of platform, including a long-term platform as a floating station and a moored observatory, but also instantaneous station. And we combine this fieldwork activity with the laboratory incubation experiment and modeling exercise. The main fieldwork are two contrasting marine ecosystems located in the Southern Ocean and in the Mediterranean Sea. So from British Antarctic Sur, we can cover, of course, the Southern Ocean aspect, but we need a support for the Mediterranean Sea. So to address the question of CUPIDO in the Mediterranean Sea, we benefit of the facility of EMSO in the South Adriatic Research Facility. This facility includes a lot of observatory system and also mooring platform, and are operated by the OGS with the CNRESP. We focus just on one of these stations, which is located in the FF station, where there is a mooring platform. What we have done is to utilize this mooring facility that was already there and add a new piece of instrument, which we call the Ocean Plastic Incubator Chamber. The Ocean Plastic Incubator Chamber is something that we design and build up in-house in Cambridge. And it includes a series of very small chambers, which are full of different kinds of plastic that are exposed to environmental conditions. This allows us to understand the ocean plastic degradation rates in the environment. And since this incubation chamber is also a motor, the motor can also set up for how long this chamber need to be there and expose the plastic to the environmental condition. What I want to stress is that thanks to EMSO facility, there was the launch of this instrument first deployment. So it was never deployed in any kind of sea. This was the first time that we deployed it. And this was just thanks to the professional of everybody that was involved in this activity. And the deployment and the recovery was very successful. In fact, we collect 2 years of continuous samples. As you can see for this picture, everybody was super happy for that. Another activity that we have done within EMSO research, within EMSO regional facility in the South Adriatic was the deployment of a floating microplastic trap. This floating microplastic trap is also built up in Cambridge. And again, this was the first deployment that we have done. So there was a little bit of tension at the beginning, but everything went very well. The floating trap have a different collector, deploy a different depth that can drift in the water column for 24 hours. The deployment happened 2 times, and we also asked the support of course, to deploy this instrument of the research vessel Gaia Blue and De La Porta, because we want to understand how carbon and the microplastic export can interact at daily scale in 2 different seasons. So we repeated the experiment in spring and then in autumn. We collect all this data, and then we were also able to compare the data with a sediment trap, which is already part of the EMSO Regional Research Facility. We use this sediment trap to investigate all the microplastic and export collected to understand the interaction at seasonal and year scale. Back to Cambridge. We started to investigate all the sample with a different technique. This includes also infrared spectrum measurement and scan electron microscope analysis in order to understand and quantify and characterize the amount of carbon and plastic. In terms of broader and policy relevance impact of the result that we have getting using this regional facility, part of the outcome have been presented at the Intergovernmental Negotiation Committee on Plastic Pollution in South Korea, and we advocating for include the interaction of plastic and climate change in the plastic treaty. In terms of future direction, we are working on 3 papers that are in preparation, and 3 of them will be likely submitted at the end of this year. Then, of course, we already submit some abstract to international conference to present the results. And most important, the data that we acquire in the South Adriatic will support the modeling effort of CUPIDO in the other regions. So this was my last slide. Thanks a lot. Grazie mille. This was a fantastic experience, and I'm really looking forward to keep going to work with the EMSO program. And a special thanks to Stefano Miserocchi that was helping and support us in this journey all the time. Thanks a lot.
Thank you very much, Clara. I would ask you to stop sharing so that I can give the floor to the next speaker. Next speaker is Branislav Vrana. He's Associated Professor of Environmental Chemistry at Masaryk University in the Czech Republic. He's a PI at Chemodynamics of Environmental Pollution Research Group, and is also PI in the subgroup Aquatic Chemistry within the Chemodynamics of Environmental Pollution Research Group of Reiseton Center. He has an expertise in pollutant monitoring in the aquatic environment, development of sampling and analytical methods, and in investigating fate of chemicals in the environment. Today, he will introduce his experience with EMSO facilities for the project Monitoring Marine Persistent Pollutants in Mediterranean with Passive Sampling. So, Branislav, the floor is yours. Thank you.
Thank you, Valentina, for the introduction, and EMSO Eric for inviting me. I will share my screen. Can you see the presentation on full screen?
Yes.
Hopefully, yes. Yes, thank you very much. So my presentation now in this slide has a longer title, but this was the name of the project for which we applied at EMSO Eric. And basically, we look at contaminants, anthropogenic contaminants present in surface water, in oceans, and use the EMSO Eric platform for doing our observations within a larger monitoring network called AquaGAPS Monet, which I will explain. The motivation of our research is that there are man-made chemicals around us which are long-lived, persistent, and undergo very often a long-range transport. That means they enter the biogeochemical cycling between the spheres, between atmosphere, ocean, and other compartments. And the problem is that, for example, persistent organic pollutants are monitored regularly in the atmosphere as a part of implementation of the Stockholm Convention, but monitoring data of these compounds from open sea is rare. And when there is some data, it's also only regionally measured and not using a consistent methodology. And onto the top, when we look at the exchange of compounds between water and air, simultaneous monitoring in water and air is even rarer. So EMSO ERIC provided us a very excellent opportunity to perform our observations in the surface water of the Mediterranean. We performed our measurements at the E1 M3A static buoy in the Cretan Sea, which offers a unique possibility to perform long-term water and air quality observations in an area that is not impacted by local pollution sources. That is really a remote site, pristine site. And the contaminants that we measure then in water or in the atmosphere typically originate from long-range transport. So the objectives were to measure these levels of these compounds in surface water and in the layer of air over the surface of water, and investigate also seasonal variation of occurrence of these compounds in surface air and water, surface water and air, and look also at the later in data interpretation and at the seasonality of the contaminant fluxes between surface water and air, like deposition or emission from the sea to the atmosphere. The activity on the map you can see in red is the sampling sites, but the activity is part of a larger monitoring initiative which is called AquaGaps Monet, which is ongoing already for a couple of years. Since 2016 till 2020, there was a pilot campaign where we successfully exposed samplers at 43 locations, 40 marine deployments were done and 22 freshwater deployments, and we published some data from it. And now we increased the geographic coverage, but we also, thanks to the access to infrastructures like that from EMSO ERIC, we are able at several sites also to observe long-term temporal trends of contamination in marine water. We use passive samplers as a tool for monitoring. There are very simple non-mechanical devices which consist of a polymer material which behaves like subcooled liquid, and during exposure to water it accumulates by partitioning contaminants from the environment, and this way we can accumulate enough compounds for quantification by instrumentation in the laboratory. And then the material fulfills the criterion for the environmental monitoring, that the matrix of collected samples should have defined constant properties over time and space. So this way, when actually in a very simplified way, when this sampler equilibrates with surrounding water, the levels found in the samplers at the different sites or over a different time scale are mutually comparable on a global scale, which allows to really investigate the fate of contaminants on a global scale. So what we used in this case there was a suite of 3 different water samplers. One is on the left-hand side is silicon sheets for hydrophobic, poorly water-soluble, neutral organic compounds, then a special sampler for perfluorinated compounds, which is a development from University of Queensland in Australia. And then on the right-hand side, it's the speed disk sampler, adsorbent-based sampler for hydrophilic polar compounds, water-soluble. And then we had also this polyurethane foam passive air sampler, which we installed simultaneously on the marine buoy, with a great help of the regional facility, the Hellenic Center of Marine Research. There were several subsequent 3-month-long exposures of the samplers. So you can see in the middle is the holder for the aquatic samplers, and on the right-hand side, the colleague is holding the aquatic sampler before deployment to water in his hand, and over on the mast there is hanging this air sampler. This campaign is still going on. So far, 2 seasons were covered in 2024, and in 2025 another 2 seasons of sampling are planned. These are the typical groups of contaminants that we are going to look at, but we will maybe go even beyond targeted analysis of contaminants to screen for new, unknown, emerging contaminants in water. We had a remote access, so the colleagues from Hellenic Center for Marine Research did the deployments for us, and we received then the samples shipped to our laboratory, where we extract them and measure by typically chromatography coupled with mass spectrometry, and do the conversion of accumulated amounts to freely dissolved aqueous concentrations or concentrations in the air. And these are just examples like what comes out of such measurements. It's graphs showing the levels of aqueous concentrations of, for example, polycyclic aromatic hydrocarbons, brominated diphenylators, organochlorine, pesticides in surface water. And the levels, because it's a pristine site, are typically very low. It's in picograms or even femtograms per liter level, but still very relevant because these compounds are bioaccumulative, many of them, and in the marine biota they can reach like several orders of magnitude higher concentrations at present, even often a risk to vulnerable aquatic ecosystems. So, and this we will bring into context of the Stockholm Convention. That means the PFAS data is even reported to the Conference of Parties to the Stockholm Convention as a part of measurements in the global monitoring plan. And then the other compound measurements will support the publication activities where we investigate the seasonality of occurrence of the monitor substances in water and air as basis of future long-term trend monitoring, because we need to know how much the concentrations fluctuate over a year, whether there is any seasonality. And then also what is of interest is how this seasonality affects the diffusive air-water exchange of compounds. And of course, it will support the ongoing collection of data under the Aquagap's MONET global monitoring initiative. So I would like to express my thanks to EMSO Eric, the regional facility, Hellenic Center for Marine Research, the Poseidon operational system, and special thanks to the colleagues who did the sampler installations, Manolis Tsapakis, and colleagues from the Poseidon team on Crete. And thank you for your attention.
Thank you very much, Branislav. I would ask to stop sharing. And now is the time for the Q&A, even if we are a little bit late. Have received a question in the chat. Are there opportunities to test innovative UVs for monitoring intervention capabilities? For example, do sea facilities have underwater structures that require monitoring? I think maybe, Simo, you can start with a reply.
Yeah, sure. There are the facilities offered. They have structures, different depths. They have moorings that could be monitored down to 1,000, 2,000 meters. So yes, actually, this is a topic that we are now talking about in EMSO to see how the AUVs could help monitor these our facilities and so on. So this would be a very timely project for us. And you are welcome to contact us and to know better the different facilities available, and we can guide you through the process. And I don't know if Christoph wanted to add something to this topic, because he's an expert on AUVs, and maybe Christoph, you can answer to Manno, and maybe you can also give how do you see the future of the fixed point observatories together with AUVs and artificial intelligence and so on?
Yes, as I mentioned in my presentation, I think there's a lot of opportunities that are offered by this combination of underwater vehicles and AI methods. And coming back to Manno with his idea of testing innovative AUVs, for instance, OPSI will be very well suited because there is a buoy where you could install navigation equipment to track your vehicle, to see what is actually doing. That was our motivation to go there. And so that from that perspective, it's very good infrastructure to test that. On the other hand, I do not see that there are any interesting underwater structures that should be investigated. Probably you have to go to other places, but maybe you can split off your tests. First, the technical aspect of your AUV, and then go to a different site to check for underwater structures. Thank you.
Thank you, Christoph.
Thank you very much for the answer. And if I understood correctly, there is a possibility to monitor mooring and a buoy, if I understood correctly, right?
I think, Simo, you can mention also INGV.
Yeah.
In Italy.
Yeah, for example, INGV has a very deep cabled observatory. For example, there you could have your AUV having a look at there, for example. So I think, for example, they have issues with the ashes coming from the volcano that cover the observatory. You could go there and check what's going on, for example. Things like that. There is a lot of applications that could be useful for us. Yeah.
Thank you also for the question. I don't know if there are any more questions from the public, from the audience. Otherwise, I think I can briefly ask one question to Branislav regarding the Aqua Gaps network. My question is, will the Aqua Gaps network will be extended, and maybe what's the future of the initiative?
Well, the initiative is initiative by scientists from several institutions, like our Masaryk University. The Recetox plays a role of a central laboratory at the moment. And then there is University of Rhode Island in the United States and University of Queensland in Australia, and also in China we have a partner. But the activity of the network is at the moment on a volunteer basis. That means like we manage to distribute the samplers, but we really depend on local scientists or enthusiasts to deploy the samplers for us. So far, we have no long-term sustainable financial support. From time to time, like it's when it comes, for example, for PFAS monitoring, we get some support from UNEP. And then we search for opportunities in access to research infrastructure. So it's a lot of work to keep this network running, but the ultimate goal is to make this network a permanent one with which will really demonstrate what is the fate of contaminants, emerging contaminants on a global scale in future. The pilot study really demonstrated that this is feasible. So we hope that in future we get also some like more project funding. So we are searching actually for partners and for opportunities to continue.
Thank you, guys.
Yeah, and thanks to EMSO, Eric, this really can happen.
Thank you. Yes, so I think that at the moment we don't have any more questions. Thank you very much again for your participation. Thank you to the speaker for presenting us their experiences. And thank you for the attendees. And we are very welcome to address your question also via email. So for whatever reason, you can reach us through our social channels or through emails that we show in the slides. Thank you very much, and enjoy your weekend.
Thank you.
Bye-bye.
Bye-bye. Have a nice
Thank you very
weekend.
much.
Thank you.
Bye.
Bye-bye.
Thank you to the team also.